unwrapping our weapon. In this chapter, in the form of an edited and commented live demo, we will create the final UVs of our weapon, using the methods discussed in the previous chapter. Welcome to UV Unwrapping. As always, we start every new step with the cartridge. Shading is already done and dusted, and we know that sharp edges require UV cuts, so we start by selecting a sharp edge and hitting Shift-G to select the edges with similar sharpness. We mark all of these as UV seams and do a quick unwrap. We can see these seams are not enough for a correct unwrap, because there are no straight UV shells in the result. To fix them, we will need to add some extra seams that are not tied to sharp edges. These should be as hidden as possible. We add a checker map quickly with the UV Toolkit add-on to clearly see the UV warping. You will notice the front of the bullet is still extremely warped, so we add some extra cuts to it. We hit the U hotkey twice for a quick unwrap, and check how our seams are working. We can also use Live Unwrap, which will run and unwrap every time we do any change to the seams, but I prefer to run it manually to avoid losing any shells that I worked on but forgot to pin. Now that the deformations seem under control, we straighten the UV shells with UV Toolkit. The more square-shaped objects can get extremely good results from the first unwrap, based solely on hard edges. Notice though that there are two rings that are a different shade of blue in the UV editor. Anything that is not dark blue means the angles of the UV faces do not correspond to the angles of the 3D faces, and they most likely are not unwrapped correctly. To get this color view, simply activate Display Stretched by Angle in the Overlays menu. In this piece, we just need to add a couple seams to the cylinders that house the screws, and that's it. We now unwrap our first complex piece, the barrel. There appears to be a faulty UV island that is causing errors, so we activate the UV Sync mode to identify it. This mode is extremely useful to find out which UVs correspond to each part of the mesh, especially in more complex models. Unfortunately, this mode does not allow us to run many of the UV Toolkit operations, so we end up in a kind of Schrödinger's UVs. We can observe them in 3D and 2D, or we can operate with them, but not both at the same time. This means we will be constantly changing between UV Sync on and off, whenever we need to identify specific UVs in 3D. With UV Sync off, we need to select all faces in the 3D viewer to be able to see their UVs. Of course, we can select just a few and we will know where they are in the 2D view, but we will lose the context of where they are respectively to other UV islands. Having tried all the other 3D packages out there, I can only expect this aspect of Blender improves in the future, as right now it is very inconvenient. This unwrap seems good enough, but many of these islands display long edges that are slightly rotated, which could cause baking issues. We fix this with the Align to Edge button from UV Toolkit. Because of the square nature of pixels, any mesh that is planned to be textured should be as aligned as possible to the orthogonal UV grid to avoid aliasing or stepping artifacts along its borders. This is especially important when using lower texture resolutions. When a UV shell is ready to go, I like to pin it using P to avoid it unwrapping any further. It's also better to move it away from the 0 to 1 UV space, because further unwraps will fill it completely and it can be confusing to have our shells overlap. Also, be aware that the more shells we pin and move out, the bigger the remaining shells will be unwrapped and packed. Remember to average their scale at the end. Even if a long UV shell appears to be straight, we should still align it to its longer edge, just to be sure. In this case, the island had a very slight slope that wasn't easy to spot. With all shells unwrapped now, we see a problem. The inside of the barrel seems to have a fairly big amount of deformation. Check out how the UV checker squares are not square. How has this happened if we unwrapped everything the same way? Well, there are two unwrap algorithms in Blender, angle-based, which is default, and conformal. The angle-based algorithm has one flaw. Since it only looks at face angles, it does not unwrap very thin and long faces correctly. It is not good at determining the length of the UV shell, and can result in them being squished and out of proportion. For this reason, I prefer to use the conformal method for hard surface modeling. Whenever we need to re-unwrap a shell, we can just unpin it and hit U again. We can normalize the texel density of our UV shell selection by clicking UV and then Average Islands Scale. It is a command I use a lot, so I added it to the Quick Favorites menu on the Q key. We will not be able to extract or input any texel values though. For that purpose, we use the Texel Density add-on. Since the basics are covered already, for the rest of the video I will focus on tips, exceptions, and special cases. By now, you should be familiar with the unwrapping process, so let's do a quick recap. First, we apply a seam to every hard edge and do an initial unwrap. Then we add extra seams to the parts that don't unfold correctly. Later, we straighten and align the shells that need it, move them out of the 0 to 1 UV space, and pin them when complete. Finally, we normalize the UV shell scale to keep a consistent texel density. In shells with irregular faces, or anything that is not quads, we will not be able to use straighten shell operator, but we can straighten them up manually by aligning their vertices. Often I use straighten while selecting only an island's square faces, then pin them and unwrap. Since part of the shell will be pinned, the rest of it will try to accommodate to these pinned faces. This is how we relax UV shells in Blender. Here is another example of relaxing a UV island. We want to make this strip of edges straight and vertical, but we also want their connected faces to unwrap correctly. So we first pin the left part of the shell that is already correct, and then select the vertices, align them to the right, and pin them too. Finally, we simply unwrap again, and the unpinned faces will adapt to the shape we want. Another example. This time, we relax these islands from a pinned straight middle axis. To solve this unfolding error at the bottom of the shell, we apply the same principle. Straighten an edge loop, pin it, and unwrap. We also want to straighten the outer edges. We simply select, align, pin, and unwrap them again to adjust the inside faces. two pieces stand out here, the two strips of quads we left behind the grips. Since they are very thin, we can just cut them in pieces and straighten them to optimize UV space. The Grip 01 UV shells seem correct already, but we can make them even better. We know that this grip is made of wood, and we can enhance its realism by making the wood pattern bend according to the shape of the grip. We straighten the middle edge loop using the Straighten Selection button. As we can already see in the 3D viewer, now the checker squares perfectly bend following the grip shape, instead of simply being orthogonal to the bottom of it. Finally, here is the end result of the unwrap. Note that, since the UVs are not properly packed yet, the textile density is a bit all over the place. This will be fixed later during the baking process.